Alex, I had a fantastic day at work talking about Neanderthals and dinosaurs.
Yeah.
Yeah, we had to convince a coworker that they were real.
Interesting.
Yeah.
Interesting. For those out there, they are real. They did exist. Keyword did. They no longer do. Obviously we have dinosaur fossils. We do have Neanderthal fossils. Fossils, I guess, they haven't been extinct that long, but you can still see they were close enough to humans. There are still some humans that they have found that have a pretty decent amount of Neanderthal DNA
Yeah, a
within
lot
them.
of us at work have done the DNA test, and I know a couple have come back with, 5 or 6% Neanderthal in them. But yeah, I thought it was pretty interesting. It was a solid 2-hour conversation that ran through my lunch break. So, yes, they are real. Dinosaurs are also real. Believe what you want, but do not, deny the science behind things. That's all I really had for that. But welcome to Life the Complete Story. I am Tyler. That is Alex. We are here to talk about nature and nature adjacent things. Make sure to follow us on Spotify, Amazon Music, Apple Podcasts, iHeart Podcasts, wherever you listen to podcasts, as well as Instagram, TikTok, and Facebook at Life Complete Story for news articles, amazing species, as well as short form content that we post. And make sure to send us an email if you want at lifecompletestory@gmail.com for questions, concerns, things that don't quite fit in the comment block. Jump into our first segment as we always do with our nature in the news. Alex, I just told you this is from the American Chemical Society, and we are turning ocean plastic into roads. So one of the biggest problems in the world right now is this giant pile of trash in the middle of the Pacific Ocean. I think it's just called the Pacific Ocean.
The
Trash
Great
pile.
Pacific Trash Patch, I believe.
Yeah.
Or the Great Pacific Garbage Patch. It is, so for context, spans roughly 1.6 square kilometers. So it is about 3 times the size of the country of France. So it's not really as you would think a patch is an accumulation of plastic from around the world located kind of in the North Pacific between California and Hawaii. It is kind of a dispersed, quote unquote, soup of about just under 2 trillion with a T plastic bits. That's approximately 100,000 tons of trash.
So how this relates to our article is we're taking plastic and making roads out of it in Hawaii. Hawaii is a very tropical climate, has a lot of wetness, a lot of cracking and rutting in the roads. We live in Pennsylvania and our roads are terrible because it rains every other day.
And salt.
And salt, because that's what we use to clear the ice and snow. So it heats up the water and it cracks the concrete as well. So they use a PMA, which is a polymer modified asphalt, which gives it a little bit more flexibility, a little bit more able to handle that cracking and water damage. So what they do is they melt down butadiene-styrene, which is a plastic pellet, and they use that as the binder between rocks and sand and typical asphalt materials. So now we're seeing if some of this brand new PMA that's like freshly made can be replaced with waste plastic, which if it does, that's big news for the rest of the world. We can kind of start clearing this trash. We already try to clear the trash pile. It just grows at an exponential rate that is almost wipes out any effort we make. So the Department of Transportation is partnering with this chemist to lead the research on whether or not discarded plastics will work. And I'm sure it's also a lot cheaper in terms of economically speaking.
Because maybe a lot of times, sometimes it's cheaper to make things fresh, but if they can do it relatively cheap comparatively as well as recycle, I think that would make it very interesting. Or people would want to use this over other things.
So one of the things they did was they took samples from current roads that are already there, that are already made of this PMA, to test for what typical road dust for microplastics and larger plastic fragments, seeing like as a baseline, okay, well, this flakes off this much over this much time and it releases this many microplastics. That's the big craze. Everybody's scared of those too. And that way we can compare over a similar amount of time how this recycled plastic works. So this isn't this study, and then compare. This is a time. This is going to be a 2 to 3 year study just to determine if it'll work before we can even start.
Yeah.
Anything else to add, Alex?
Big thing they're looking at as well, because it's kind of a big thing in the news. They're looking at how much microplastic is being shedded in this from the road dust. So, which I'm guessing is just the small bits of asphalt that kind of wear off over time, and using a mass spec or mass spectrometry to figure out where the materials came from, and the analysis identified that the styrene and butadiene from standard PMA versus the recycled plastic and fishing nets, or the isoprene and butadiene rubber from the vehicle tires, because if people didn't know why your tires wear out, is that little bit of friction between the road and your tire over time does wear off a little bit of the rubber. It also wears off a little bit of the road. Obviously the rubber is much softer, so it wears faster. But just to determine what exactly is this dust, like how much is it?
It's a low percentage of microplastic in comparison to typical road dust.
Yeah, is it actually better, because then you get less microplastic loss over time? There's a lot of different factors in that, but it is pretty cool.
That's all I had for today's article. I think you covered it pretty well as well, Alex. That'll take us into our lesson. Last week we covered our intro to Squamata, as well as our first family Dibamidae, which were those blind skinks. Today we're moving into our first super families. We'll have 3 families we're talking about today. The super family is known as Pygopodomorpha, or Pygopodomorpha, however you want to say it. This is a super family of geckos, including 3 Australasian families, so they're found in Asia and Australia and Oceania. They include the stone geckos, knob-tailed geckos, and the flap-footed geckos. Originally, the stone geckos and knob-tailed geckos were subfamilies in Geckonidae, which is a family we'll cover in the next coming weeks, before molecular work placed them as a sister taxa, putting them into this superfamily. And our first group we're going to talk about today is Diplodactylidae. These would be the stone geckos. They are a family within the suborder Gecko and the superfamily Pygopoididae. They are found in Australia, New Zealand, and New Caledonia. They're the most widespread and diverse family of geckos in this area. They live in warm regions between 75 and 85 degrees Fahrenheit, or 24 and 29 degrees Celsius. They live in rainforests, typically higher up in the trees for protection, although they can also be found in cooler climates like southern New Zealand, closer towards that Antarctic Circle, at temps of up 1.4 degrees Celsius, which is really cold for a reptile.
It is very cold for a reptile.
Since they're cold-blooded, they need the sun to kind of like bask and warm up their internals. So being at 40 degrees Fahrenheit-ish, 36, is rather unusual for something of this. Some members are viviparous, although it is more common to have oviparous breeding techniques. Most of the time they lay a clutch of 2 eggs in geckos, and they're they have a different shell type, not quite the leathery shell we'll talk about eventually, but more of I think it's like a sandpapery shell. Nearly all members exhibit a toe pad. So if you ever have a pet gecko, they kind of like to stick to the walls and hang upside down. They have toe pads similar to amphibians, but these ones, their toe pads is a whole bunch of little tiny lamella, I think is the right word I want. And they're tiny little fibers on your toes that trap the air between their toes and the surface, allowing them to stick. And they, based on studies in captivity,
almost acts kind of like a suction cup.
Yeah.
That's why geckos can scale pretty much vertical walls.
Yeah, kind of like the sucker that sticks into your, when you hang things up in, your windows. Like that, where it traps the air. Although based on studies in captivity, they prefer to grip onto more coarse objects, bark, sandpaper, than a smooth glass. Probably just because it's what they're used to in their natural habitat.
Yeah, and it's probably easier.
And we have a variety of genera here. We got the velvet geckos, known as Amylosia. The Bavayeas, known as Bavaea. Corylophus is the crested geckos. Cranodactylus is the clawless geckos. Dactylonemus is the Pacific gecko. Gecko is the striped geckos. Diplodactylus is the stone gecko or the fat-tailed gecko.
And that is what I have pictured.
That's what Alex pulled up. Eurodactylodes is a group of chameleon geckos. Hesperodura is the reticulated velvet gecko. Hoplodactylus is the New Zealand giant geckos. The extinct Gigacarnum. Leucacium is the ground gecko. Niara gecko is the mossy gecko. Mokopiraraku is a group of New Zealand geckos. Naultanus is the green geckos. Nebulifera is the robust velvet gecko. Oedodera is the marbled gecko. Oedura is a group of velvet geckos. Pania gecko is a single species genus. Pseudothecadactylus is another group of gecko. Rhacodactylus is the giant geckos. Rhinochoedura are the beaked geckos. Strophurus is the spiny-tailed geckos. Toropuco are a group of striped geckos. Tucutucu is the harlequin gecko, and Woodworthia is a group of New Zealand geckos. Alex, would you like to talk about the next group?
Yes, sir. Our next group is the family Carphodactyl. These are southern padless geckos. There are 34 species within 7 genera. They are a sister group to the flap-footed geckos, which we would talk about next. Despite having very well-developed limbs, many members also have specialized tails, reducing the rate of autotomy, which we will talk about later. They use sharp claws rather than toe pads to cling to bark. They are fairly large geckos and typically nocturnal and oviparous, laying 2 eggs per clutch. And the species diversity is concentrated in humid forests along the northeast of Australia. Like I said, there are 7 genera. There's Carphodactylus, the Australian chameleon gecko. Nephrurs is the knob-tailed geckos. Aurea is the long-necked northern leaf-tailed gecko. Phylurus is the Australian leaf-tailed geckos. Saltarius is also the Australian leaf-tailed geckos. So there's 2 groups of those. Underwoodosaurus is the thick-tailed gecko, and the Uvedicolus is the border thick-tailed gecko.
That'll take us to our last group, as Alex kind of alluded to, Pygopotidae, which are the snake lizards or the flat-footed lizards. They get their name because they are longer and more slender than the rest of the groups we talked about. They have reduced or absent limbs, and they do fall under this Geckotus suborder. There's 47 species and 8 genera. They have long, slender bodies, making them resemble snakes. They also have no eyelids like snakes and geckos, and so they kind of have to lick their eyes to keep them moist. If you've ever seen that in a pet gecko or anything like that. However, they do have external ear holes and an unforked tongue, similar to the other geckos. They have no forelimbs at all in any species, but some species do have a hind limb flap that's either used for courtship or defense. We either haven't done enough research to know, or it's very species to species. They are able to vocalize like other geckos. They kind of have a high-pitched cry. They can hear tones higher than other reptiles. At a 60 decibel level, they can hear frequencies at over 1100 hertz, which would be an octave higher than the highest note on a piano. And the genera we have for this are Lialis, Delma, Paradelma, Pygopus, Ophidiocephalus, Aprasia, and Pletholax, while your genera for snake lizards or flat-footed lizards. And that's all we have for today's lesson. Relatively short. We're trying not to slam a whole bunch together, because that tends to get long-winded and boring for the both of us, as well as the listeners, as well as we have other things to talk about. So, Alex, I'll let you hit it off. You can choose whichever one you want.
I'll start with our oncology encyclopedia today because we already kind of alluded to it. So we are talking about autotomy or autotomy today. This is a defense mechanism where an animal will voluntarily shed a body part, kind of as I said, is something that is very common in lizards, specifically the geckos and skinks. It is called caudal autotomy, caudal tail. So they will actually purposefully like drop their tails or like remove their tails to escape from predators, and the tail will actually continue to kind of wiggle for even up to a few minutes to kind of confuse, disorient, as well as grab the attention of the potential predator, so that way the gecko can escape. And they do grow back. So this is not something that they just do and then
Yeah, it's not a one and done, one trick pony type deal.
Yeah.
It will regrow. It does take quite a while for some species, but it will.
Yeah. And the kind of cool part with this process is this appendage will kind of come off on a predetermined what's called a breakage plane. It's built into the anatomy of the animal. So it has specialized muscles as well as cellular chemistry. That way, when like the tail comes off, it will seal the wound pretty much instantaneously. So that way it doesn't just bleed out. So that's why this is a useful survival tactic, because it allows the sacrificed body part to become the focus of the attention to the predator, allowing the gecko, lizard, whatever it is, to escape. And this does happen in other animals as well. Crabs and spiders are known to do this. They will shed limbs. Different stick insects and grasshoppers will drop legs, and as well as some, and a notable one as well as bees, because they have their stingers are barbed, and it will leave behind the stinger in a venom sac in the target. Pretty much this is just some of the social bees, like honeybees is the prime example. However, this one's a little different because this does result in the death of the bee. So not as more of a kind of a proactive rather than a reactive defense mechanism, because that does cause the death of the bee. And a lot of this, where it regenerates, there's lost limb in lizards. It may be different in what it looks like and how well it functions, though. The original tail, of course, is the best, because this regrown tail may be different in coloration and will typically be made up of cartilage instead of bone, so it's not as strong. Now, usually they do not use their tails for climbing, like they're not prehensile, it's more balanced. And with that, during the time this tail would grow back, they do see reduced mobility. Like I said, that balance kind of control, especially on climbing surfaces or at very high speeds, they will kind of throws off their balance. They have decreased reproductive success because you think, oh, something's wrong. Like a male versus a female, male without his tail is going to be less attractive, and it may suppress their immune functions to prevent infection from the site where the tail came off. So this could lead to disease. But that is all I have for autotomy.
All right, I guess I'll move on.
Tyler?
I don't. Not for.
Okay.
The starfish do autotomy actually, or is that more of the we regrow whenever it happens? It's not.
It's more we regrow whenever it happens. They don't do it voluntarily in many cases.
And I guess like jellyfish are the same way then too, where like something bites off their tentacle, they don't. It's not like a breakpoint type thing. That'll take us to our amazing species for today. Today I have the rough gecko, Naultanus rudis. These guys are endangered, assessed in 2018, published in 2019. They're found on the northern portion of the southern island of New Zealand, in a couple national parks or nature reserves. Their extent of occurrence is a little bit more than 3,500 square kilometers, but they only occupy about 68 square kilometers of that region, with several severely fragmented populations. And the quality and extent of the habitat continues to decline. Not just because of human events, there's also some natural occurrences that happen that have kind of ruined bits and pieces of habitat.
Yeah, it is. They are closer to the coast, so that may be part of it.
Yeah.
In some cases, a lot of major river systems, so I'm sure flooding plays a pretty big factor.
Yeah, so they are continuing to decline in terms of a population trend, only containing about several thousand individuals. Hitchmau, who's a researcher for these guys, implied that there were no more than 500 mature individuals in the largest subpopulation and no more than 15 subpopulations. based on records from 15 localities. So if each locality has its own subpopulation. And it's also about 10 to 50% over 50 generations, which isn't the worst we've seen when we've talked about these over the 80 some episodes it's been. But it's still a decent chunk, especially whenever we're talking about a smaller organism in a severely fragmented population. They do live in forest and shrubland environments, kind of coastal, semi-coastal. In terms of threats, it's mostly livestock farming, hunting and trapping, invasives, which is an unknown invasive, mostly rats and cats, mammalian predators, and a magnitude 7.8 earthquake in 2016 impacted one of the major areas this group lived, like this species lived, ruining part of their habitat. And they used to be heavily poached, but that kind of has diminished over the past couple years. They are nationally and internationally traded, but still poached for personal collections in terms of like pet hobby, stuff like that. And they are in protected areas and included in the national legislation for endangered species and protection of New Zealand. That's all I have for these guys. You got anything, Alex?
I do not.
We'll toss it back over to you for your most wanted.
Yes, sir. Our most wanted for this week was the Green Iguana. The Green Iguana is something that is found in the southeastern United States. They're a tropical species of lizard, very large lizards, growing exact size from these guys, but they'll grow a couple feet in length. Sorry, they can grow, the males can actually grow over 5 feet in length, but I'm sure a good chunk of that is tail. They can weigh up to 17 pounds. The females can get usually that large, but they don't typically weigh that much. They do not exceed 7 pounds. They're reaching reproductive maturity at 2 to 4 years of age, and they will lay between 14 to 76 eggs in underground egg chambers that can be nearly 80 feet of interconnected tunnels with many entrances. They can live 10 years in the wild and 19 years in captivity, and they are capable of living pretty much anywhere on the ground, shrubs, up in trees. They can swim very well, tolerant of both salt and fresh water, can submerge for up to 4 hours at a time, and they're comfortable in any environment, suburban, urban, small towns, agricultural areas. They eat a wide variety of vegetation, mostly as adults, shoots, leaves, blossoms, fruits from many different kinds of plants. And they do have a tendency to eat ornamentals, which makes them a nuisance to homeowners. They will also eat on bird eggs and dead animals. Juveniles will feed on vegetation, insects, as well as tree snails. They are native to Central America and the tropical parts of South America, some of the Eastern Caribbean islands. But in Florida, they were introduced in the 1960s, kind of in the some of the coastal areas and into the Keys, and have since expanded because they really don't have a predator. They're not like, other than having the spines on their back, the fact that they're so large means that most predators in those areas cannot get at them, as well as them being very good climbers and actually very fast when they try to run. So think some of the larger predators like snakes or alligators, they can get them sometimes, but not enough to catch up with them, especially with the amount of eggs that they lay each time. And they damage infrastructure from those burrows that they dig, collapsing sidewalks, seawalls, canal banks, and then they will leave droppings pretty much anywhere that they feel like. And they eat native and endangered species of tree snail, different plants, and they can actually transmit the bacteria Salmonella to humans through contact with water or surfaces contaminated by their feces. So mostly just annoying. They They can be harvested, hunted in Florida. They are not protected by except by anti-cruelty law, and can be humanely killed on private property with landowner permission, and as they are not required to be hunted using a license. So that you can hunt them at will in Florida.
On
That is
private property.
Yeah, as well as in
Public.
the public lands as well. Yes. So yeah, because they're invasive, they really have no protections other than, of course, cruelty, which going above beyond of the harvesting in good faith,
Right.
purposefully causing unnecessary pain or harm to the animal, which most people that hunt, that is not their goal. That is an extenuating thing that is people who want to do things like that, and that is a whole separate conversation. But people who typically hunt, they just want them gone in this case, and they do so quickly and humanely. That is the key word, is humanely, which is basically as fast and causing the least suffering as possible.
Right. Long story short, green iguana are cool, but they're also major pests. Plus, they hurt. They got really sharp claws and
They do.
and short teeth.
Yeah, they've got some decent teeth on them as well. It is funny though, when they get cold, they will just stop
Drop out of the
moving,
trees. Yes.
and they will just drop out of the trees. They've actually caused injury to people in that case. So if you live in those areas and it gets cold, watch your head. Yeah, that's all I have for them. If we want to take it over back to Tyler for our last segment for today.
We're hopping to the time machine. We're going back to the Cretaceous period, talking about Sarcosuchus. Now, this isn't a lizard. This is an ancient prehistoric crocodilomorph. But there's not a lot of extinct geckos. But Sarcosuchus is basically the largest in terms of size genus of crocodilomorph. They were gigantic, over 30 feet long. And these is back in a time whenever crocodiles had pretty long legs for a crocodile and were rather mobile out of water as well as in the water.
Yeah. It's kind of scary to think of crocodilians that could run fast, almost gallop.
As I said, they grew over 30 feet and they could reach over 4 tons.
That is huge.
Yeah. Had telescoped eyes and a long snout, which is about 75% of their skull, 35 teeth in each side of the upper jaw, while the lower jaw had 31 teeth on each side. Upper jaws were noticeably longer than the lower one, which left a gap between them similar to some species today. And the snout kind of came over with that overbite as well, with where their nostrils were at. They had osteoderms, which is a type of dermal scute, kind of like a bony growth. You'll see that in modern crocodiles today. We'll talk about that a little bit further down the line, actually a lot further down the line.
Yeah.
Yeah, but they were massive. Yeah, in terms, about almost double the length of some of the largest saltwater crocs today. And we found this species, Sarcosuchus imperator, I believe was found in Niger by French paleontologists. Obviously, they had a pretty hefty diet, similar to a Nile croc, which has been large terrestrial prey, mostly probably smaller dinosaurs, probably, I don't know anymore. I had a whole bunch of dinosaurs in my head before we recorded, and they're all gone.
Yeah, I can't think of any. I'm having a similar brain fart.
But they weren't able to do the death roll, we presume. So that probably means that they hunted larger prey that they could just kind of bite and not have to roll to knock out. That's really all I have on these guys. Anything else to add, Alex?
No.
Massive, scary crocodiles.
Yes, very large, scary crocodile.
But that'll do it for today's episode of Life, the Complete Story. I was Tyler. That was Alex. Make sure to follow us on all my platforms, YouTube, Spotify, Apple Podcasts, Amazon Podcasts, iHeartMedia. Follow us on Instagram, TikTok, Facebook. Send us an email at lifecompletestory@gmail.com. Subscribe to the website at lifecompletestory.com. I might start doing newsletters once we have more things to talk about. We're starting to get back on schedule. There was a solid 2-month break between amphibians and reptiles, it felt like.
I don't know if it was 2 months, but it was an extended break.
It might have been an extended break before we talked about Sicilians that went to an extended break before we talked about reptiles. So there's like 1 episode in 2 months. But neither here nor there. We're back. We're recording every week for the most part.
Doing our best.
Until that changes. And we're flying along. We got more reptiles to talk about next time. I've been Tyler. That's been Alex. Alex, what do we always say?
We always say at the end of every episode, keep on learning, learn something new. You never know what you find interesting. Again, I've been Alex. That's been Tyler. We thank you for joining us.